And for today's first problem, we're going to be doing the Lewis structure of sulfur hexafluoride. So the first thing we need to do is we need to sum the valence electrons. So we know that for sulfur, we're going to have 6 valence electrons, and that's only one sulfur atom. And then for fluorine, you know that you get 7 electrons per, and we know that we have 6 of them. So 7 times 6, 42. Add those, you end up with 48 valence electrons. All right. Step 2, we're going to write the symbols and connect them with a single bond. Sulfur is the least electronegative, so it's going in the middle. All right. Step 3, we're going to complete the octet around the atoms bonded to the central atom. So if you look at this, we see that we've already used 2, 4, 6, 8, 10, 12. 48 minus 12 is over 36. Divide that by 6. And we know that it works out perfectly where each of the fluorine atoms is going to get 6 additional electrons. So we'll just go ahead and write a star for each, indicating that there's 6 additional electrons on each of these, just for the sake of time. So now we've satisfied the octet for everything. Sulfur can accept more, so it's accepted actually 12 in this scenario. There's no leftovers, so we don't need to worry about placing leftovers on the central atom. And we don't have the scenario where there's not enough, so we ignore those last steps. To double check that this is right, we know that this this compound has a charge of 0, net charge. So we can find the formal charge of each to make sure that everything together is going to net equal 0. So for formal charge, we take the valence electrons minus 1/2 of the bonding electrons minus the number of non-bonding electrons. So for sulfur, we said that it has 6 electrons. So sulfur, we're going to have 6 minus 1/2 of the bonding. So for bonding, there's 12 total. So there's 6 bonds, so 6 minus 6. And there's no non-bonding on the sulfur atom, minus 0. So the net charge of sulfur is going to be 0. Likewise, for the fluorine atom, we know that it has 7 electrons. And then you're going to subtract the number of bonding. So we have 1 bonding. And then we know that there's 6 additional electrons on there. So minus 6. So 7 minus 1 minus 6 is 0. And it checks out for every single one of them. That is going to be 0. So the overall net charge is 0. And we know that that is the proper Lewis structure for this. So then we're going to look at electron domain geometry. So we're looking at the number of atoms, or electrons, whether bonded or non-bonded on sulfur. So we see that we have 1, 2, 3, 4, 5, 6 pairs. Come over to our chart, and we see that 6 is octahedral. Then for the molecular geometry, we see that over on the Lewis structure there are 0 non-bonded pairs and 6 bonding. So it's going to be octahedral for the electron domain as well as the molecular geometry. So we have octahedral. Octahedral. Now the bond angle, because they're octahedral, every pair is going to be 90 degrees apart. And as far as polarity, because every single fluorine is 90 degrees apart, equally spaced, the net charges, even though each individual bond is polar, they're all equally spaced at 90, so that it's going to be non-polar. And that concludes question 1.